Hi guys, today we are going to be learning about Git. So Git is a really awesome tool that I really think is going to be very helpful for everyone for their different endeavors in software engineering and really building their own projects for everything that you're going to do in school and of course for the rest of your career. So this is a lecture prepared for you guys. Alright, so let's start with the question, what is Git? Git is basically a version control system popular in the software development. So we'll go through, we'll read each of these bullet points, then we'll go back and we'll talk to them. Git is used to manage documents, computer programs, large websites, and other collections of information. It allows feature tracking, change reversal, and publication of multifaceted programs. It expedites the development by large teams of developers, permits easy confluence of work on expansive projects, and Git has vastly improved the quality of collaborative development since its inception. Alright, so let's discuss each of these in detail now. So a version control system is popular in the software development. I can tell you guys for a fact, Git is definitely popular in many assets of software development. I know that I used it personally in my own senior project, as well as the company that I used to work for, that we did use Git there as well. It is used to manage documents, computer programs, large websites, and other collections of information. It's pretty self-explanatory. Git can be seen pretty much whenever there's a lot of data that needs to be maintained, multiple people need to be kept up to date, maybe things are always changing, there's a pretty solid chance that Git could be powering those. Git does allow feature tracking, change reversal, and publication of multifaceted programs. This is very important. A lot of times a company might make a major release of something, a major build, and they might realize that they broke something. So basically we can actually look at Git here if we go ahead and let me pull up my thing, online drawing sketch. I had this pulled up, I unfortunately forgot. Here it is. Alright, we'll just redraw that really quick. So we can actually look at a linear progression of Git. So here is Git as it works kind of linearly, and these might be different kind of save points that we do have. So let's say that we are right here, this was our most recent build release, and we notice that there's a big problem with it. We can actually jump back to an old version that is stored seamlessly in Git. And we can start from here, we can restore that copy, and then start building it possibly with a different feature this time. Hopefully to avoid breaking whatever we broke last time. So let's jump back into this here. It expedites development by large teams of developers. So this is really great. You're allowing multiple developers to work on a single project at one time. Rather than maybe all of the developers need to be working on the exact same feature, some of the developers could be working on, let's say you're working for Facebook, and you have 15 developers. Maybe 10 developers could be working on a new timeline feature, and 5 developers could be working on a totally awesome messaging feature, rather than 15 all at once on one part. It does permit easy confluence of work on expansive projects, and Git has vastly improved the quality of collaborative development since its inception. Alright, so you're probably wondering, why should I learn Git? Well, Git is used by software firms throughout the professional world. As I spoke before, it was used at my old internship. I'm sure it's in use at a lot of other places. It allows the globalization of industry, remote operation by development teams, accelerates time to get software to market, popular for the myriad of hosting services, compatible with all operating systems. Most proper IDEs support VCS, version control system, software, whatever, integration for further ease of use. It is language independent and allows storage of any type of file. For example, you can store all of your different development documents in Git if you do wish to do so. So if you need to maybe store your user stories or anything like that, anything that might change, any kind of design document, you can store. Git doesn't care what kind of files. You could put a movie file. I could put this video clip file in Git. Git does not care. Let's just take actually a quick second to understand, we saw the linear progression view of Git. Now let's kind of see a kind of top-down view of Git. Alright, so up here, this is what I'm drawing right now. This is going to be what's known as, this is going to be your Git repository. Okay, so this is your Git repository. Alright, so this is your Git repository. That's the fancy name for it, / your server / codebase. Okay, so all that stuff is actually going to, let's see if I can, oops, let's Command Z that. All right, we'll just delete that. We'll go ahead and slide that in there. So all of your different code is actually going to be able to live on this server. So that is really cool. Now, we'll do a little visualization here. Well, actually, so this could be some different stuff. So you could either host this yourself. So let's just say Rowan, which would be proprietary. You could also have, we could use GitHub or something like Bitbucket. So all of these different services you can actually definitely use, and that is really what's going to host it. That's going to be your server. That's where your code lives. So let's go ahead and let's draw the code. So this is going to be the actual code. And like all good code, you know, it's going to be split into a couple of different classes, because that is how all good code is. You know, all code's got to be split amongst different classes. So here we do have a couple of classes. This is going to be our code base. These all don't necessarily have to be class files. You know, some of these could be .java, these could be PDFs, one of them could be the video. Once again, Git does not care. And then just for good measure, let's connect a couple of them. So say these two classes really need to go together, and then these three classes. Really, like if you work on one, it kind of breaks the other one, so we want to make sure that they're all treated together. Okay, now we can go ahead and draw on some developers. Let's move that down a little bit. Alright, so this is going to be developer 1, so we'll draw in there D1. And then over here is going to be developer 2, so we'll draw that in there, D2. And then over here, of course, obviously developer 3, D3, okay? Now what's really awesome about Git is developer 1 could have, let's make that look more like a D. Perfect. Developer 1 could go ahead and check out this file here, and then he can work on that on his local machine. Then when developer 2 tries to go to this file and tries to get it for his machine, Git will say, hold on there, bud. Developer 1's working on this. Are you sure that you're going to want to work on it simultaneously? And obviously you're going to not want to do that. So he can go ahead and he could take this file and work on that. Same thing with developer 3. Developer 3 is actually working on this file, but developer 3 knows that these classes are all together, so he's going to go ahead and he's going to put a lock on all of these at once, just to make sure that developer 2 over there doesn't decide he wants to go ahead and start working on this file. Now, at the same time, if the developer does, developer 2, for example, finishes, he can go ahead and he can. Developer 1 can definitely take the option to go ahead and check out whatever class that this is that developer 2 did go ahead and check out earlier. Alright, so I'm going to just repeat everything like that. Alright guys, back from the interruption, sorry about that. So as I was saying before, if developer 2 does want to go ahead and check this file back in, this class back in, it does allow anyone that might want it, such as developer 1. If he wants to grab a copy of it, he can definitely go ahead, grab a copy of it, and put it on his machine to go ahead and work on. So this is basically kind of a generic overall view, a top-down view of how GitHub does work. Anyone can check things out, anyone can check things in, and make sure that they are safe. Okay, so once again, jumping back over to this. Most proper IDEs support VCS integration for further ease of use. It is language independent, and it does allow storage of any type of file, as we did mention. Now let's discuss some brief terminology. Repository. This is going to be our repository. This is our code base over here. Clone. So let's say developer 1. Okay, so developer 2, this guy's a legend. He does not need to test his code. So we are going to say that this guy is a legend, L-E-G-E. He doesn't, N-D. Alright, so developer 2 is a legend. This guy does not need to test his code. So he's going to just download the files that he wants to work on, and then upload them, and he'll just know he works. But unfortunately, most people are not legendary like developer 2. Most people are like me, developer 1 or developer 3, and they're not that great at you know, doing everything the first time. So they're going to want to be thorough and test their code exactly as they should. So by simply cloning the repository onto their local machine, developer 1 basically takes all these classes, puts them on his machine, and then whenever he wants to go ahead and test something, he can just run it locally on his machine. It's a great system. Fork. So basically, a fork can best be looked at like this. Alright, so as we described earlier, multiple developers can work on something at once. Fork can best be described as this. This is going to be feature X, and then this is the main rest of the program. I was saying earlier, a fork is basically this. Here's our linear progression of our project. We take the opportunity to go ahead, branch out, and maybe develop a feature, something else, on our local machine. It's not going to go ahead, a fork will not affect the repository. This is going to be confined to a local machine if it is a fork. Alright, but a fork is a really great opportunity that maybe you could go and experiment with a new feature, maybe change the way something works without possibly running the chance of breaking your actual program. Okay, commit. Speaking of local, commit is basically saving things. When you want to commit something, you go ahead, you develop the system, you develop the technique, you develop some kind of method, whatever. You think it's a good stopping point, a good breaking point in the code. You could definitely take the opportunity to commit it. So when you commit it, it's basically saving it local to your machine, but you get the opportunity to log that in the Git system, and more importantly, you get the opportunity to put a message in there. So you can say, you know, I added this, I fixed this bug, whatever. That way, if something breaks, you know what to look at. Push. So push is basically when you're going to take your local commit and push it from your local machine to the code base, to the Git repository, to the server. That's what you're going to go ahead and do, is push the changes you made to the code base, and then everyone can have access to them. Pull is exactly the opposite. So let's say developer 2 made a change and we want to make sure we get the freshest changes on our machine. If we pull it, it'll tell the server, hey, send us the freshest things that you got. Alright, the next thing I want to talk about is merging. Sometimes two people might work on the same thing at the same time. Maybe two people, maybe a developer takes something and does something different. You're going to want to go ahead and merge it. When you merge something in Git, Git will pop up a little thing and it will say, hey, these are the same. I noticed these couple things different. What do you want to do? Which one do you want to pick? Then you can go in and manually edit the files, or if you're using a GUI such as GitHub, it will provide the option to you to go ahead and you know, choose which one you want through a nice graphical interface. Branch. Branch is exactly this, but not on our local machine. Branch is on this machine, on the big scary, on the server is going to be your branch. So if you make a branch, that's the opportunity for multiple users to work on something at once. Check out. Remember developer 3, he wanted to make sure that those files were safe. Developer 3 could check those out to him as well, putting a lock on them so no one else can get to them. Revert is exactly as it sounds. If we're going ahead and we're doing something and we are doing awesome and we add a new feature here, and then we start noticing that our product keeps crashing. Say that this is like, I don't know, August 5th. So we'll just put a 5 here. That's August 5th. And then August 7th is right here, and we notice our product keeps crashing. We might go ahead and look back and say, oh, it looks like the August 5th was the last update that we pushed out. What's going on? And you know, we may revert back to whatever date this was before we started having those problems. Rebase is our nuclear destruct button. Rebase basically destroys our local repository and totally rebuilds it 100% from the server. Alright, GitHub. So GitHub is a repository hosting service. of preferred use. It simplifies the management of all Git features through a graphical user interface, supports access control, bug tracking, feature requests, test management, and wikis. There are unlimited number of collaborators on projects. Some of these projects online are massive with thousands of collaborators, maybe each of them just writing 5 lines of code, but once you have 1,000 people writing 5 lines of code, that is 5,000 lines of code. If you're going to be a student, you do have mostly public repositories. I think you do have a couple of private repositories. However, if you're working on your multi-billion-dollar idea, it might be a good idea for you to go ahead and pay the $5.99 or whatever it costs per month to go ahead and have a private repository. But other than that, I think your homework should be safe on a public repository. The Git flow workflow. It is the agreed upon method for developing quality software. It's highly applicable for feature-based implementations and agile-based development. It does assure smooth progress through binding contracts. Commonly accepted as a very good way to avoid work that may inhibit progress. It is preferred workflow as it promotes a rapid development with required deliverables. Alright, we're going to discuss that in a moment. VCS integration with IntelliJ. IntelliJ is the preferred IDE for Java development because of its seamless prepackaged support for VCS integration. I personally think that you should use IntelliJ for many, many, many reasons. This is only one of them. If you do not use IntelliJ, I strongly recommend that you check it out. It is accomplished through GitHub. Account registration for easiest level of accessibility allows user to create a project from a repository through cloning. Once cloned, the project will be tied to the repository through the VCS settings and supports all operation of Git through the user interface of the IDE. There's a save button, there's a commit button, there's a push button. It doesn't get much easier than that. Alright guys, we'll discuss that demo in a little bit. In conclusion, Git should be used in this course to produce programs of a large scale on a short timeline. Git is used by professionals and is an indispensable skill in the working world. Release branches can be made to coincide with the end of each sprint and will allow the faculty to review your work. The coordination, management, and production of the work is up to you. We are more than happy to assist you with all of your questions that you may have, but let me tell you what guys, Mr. Google is a very, very good resource as well. All you have to do is ask whatever question you want and it is able to help you out. Alright guys, now let me tell you what, let me pull up my email here and I will actually show you guys something that I do think is actually a very, very awesome website that I do want everyone to take note of. That website is this website right here, http://rogerdudler.github.io/git-guide. This is the easiest GitHub guide that you can use. We are just going to scroll down like this big arrow does. This is going to be the setup. I am using Git on my Mac today. Unfortunately, I do not have a Windows machine to showcase it for you guys. However, that is okay because we are actually going to use it for Linux. So we just follow this big arrow. It points us down. And if you have never used Git before, you know, download Git for OS X. That's a good place to start. Windows and Linux. Now today we are actually going to be using Linux. So I am going to take the opportunity to connect to Linux. I'm going to use the server that we do have available to us at Rowan University, which is very awesome. Just gotta terminate that, set this up. Alright. Just going to connect to Elvis as you guys normally would. However you do want to do it. Luckily, we do not have to worry about installing Elvis on Linux on Elvis as it already is installed. So we are just going to follow this guide step by step because this is the best guide. There's also a cheat sheet. I will show you guys how to get to it. Going down here, create a new repository. That sounds like a plan to me. Open it and perform a git init to create a new Git repository. So let's see where I am in my working directory. Alright, as we can see, we do have a couple of git tests, so we'll make another one. So we're going to do a mkdir command for test for git. As we already made a couple, I'll just name this one for. Obviously, you guys can name yours whatever project you want. Alright, let's print our working directory. Alright, I haven't migrated in there yet, so I'm going to cd to that for test for git, ls. Alright, let me print that working directory. Now, I will ls here, you can see that there is absolutely nothing in this folder. So let's go ahead and let's follow the instructions. Create a new directory, open and perform a git init. Okay, I'll tell you what I'm going to do. I'm going to open this over here so it's a little bit easier for me to get to. Alright, so what I'm going to do is I'm going to follow the instructions exactly and type in git init. Initialized empty git repository. Now this is where things get a little bit more saucy. We have to go ahead and go to github.com. Go to github.com, sign in, or create a new account. I personally am already signed in as this is my home computer. And then you're going to go ahead, if this is your first time using GitHub, you're going to create a new repository, fill in the information, and all that kind of stuff. But for demonstration purposes, I'm going to use one that's already been created, such as this one. So I'm going to go right over here, this big green button that says clone or download. If I want to download a zip of this entire project, I could definitely do that. However, for demonstration purposes today, and the preferred action, because downloading a zip is really not using Git, that's kind of for backup or archival purposes, we're going to go ahead and we're going to copy this link. You do have to remember to copy that link. Now we're going to head over here, check out a repository, create a working copy of a local repository by running the command. Alright, we're going to ignore that one, and instead we are going to use a remote server. So we're going to type in git clone over here, git clone, and then we'll go ahead and paste in that link. Alright. As you can see here, cloning into Walrus. Alright, and here we are. It's going running through us what is done, and eventually it does go ahead and finish. Alright, look right up here. Remember, there was nothing in that directory. Now we're going to go ahead and ls, and we can see that there is some things in that directory. Let's change directory to the Walrus directory. Alright, ls. Alright, let's change directory. Obviously, you know, your folder contents will vary depending on what you did. I am just doing this for demonstration purposes. So I'm going to change directory to the legacy, change direction to, let's do rules engine drool, let's do the simulator. Alright, ls, cd to the source folder, ls, cd to main, ls, cd to java, ls, cd to alarm, ls, cd to alarm.java, ls. Oops, well actually we'll vi to that. Since that is a directory, we obviously cannot change to that, but we can open it up. So here's a folder I'm working on. I have to make a very important change to this folder, this file, and that is to add a spacing. The spacing is all awful. No one can actually read it, so that's why I will go ahead and put the spacing. Alright, then I'll click Escape, Shift-ZZ to save that file. Now, I don't know what to do next. I've made this file. I want to share it with all of my friends. How do I do that? I can go over here. Workflow, you don't really need to worry about this. It's just explaining things. Your local repository consists of 3 trees maintained by Git. The first one is your working directory, etc., etc. You guys can read that yourself. Here is add and commit. Okay, you can propose changes added to the index using git add or git add star. So let's just say I did multiple files, which I did not, but let's just say I did. So I'll just use the star to make sure I get all of them. So now that I got all of them, that's great. To actually commit these changes, use git commit -m and then put in your message. So git commit, let me check to make sure I'm spelling that right. Yeah, there we go. -m, and then, you know, we'll just put in whatever kind of message we want to put in. So fixed spacing. Alright, then we'll click enter, and then here it will say your name and email address were configured automatically based on your username, whatever, whatever, whatever. One file changed, one insertion. That's because we inserted one line. Now we have to push those changes. It's really nice that they are on my, let's see if I think I'm, is it here? Is it here? Yeah, it's really great that they're living on my local machine, but I do want to make sure that everyone can have a chance to do them. So how do I do that? Well, I go over here, git push origin master. So I'm going to go ahead, git push, type it in, easy as that, and then we'll say, oh, what's my username for GitHub? So I'll go ahead and type in my username for GitHub, and then it's going to ask me for my GitHub password, which I'm going to try and remember for you guys. Alright guys, we are back. I did type in my password here and everyone was able to say it, so I did have to go ahead and restart where I was. So we'll do git push, username for GitHub. I'll take the opportunity to type that in. Now password, hopefully I get it right this time, guys. Alright, I got it right that time. So, unfortunately, last time I shared my password, so I had to take that out of the video. But, you can see here that it did work, and usually it works much more quicker and a little bit more convenient than that. Alright, so there we go. Now those changes are in the repository. Now anyone that wants to go ahead and can download them can do them. How would you do that? This guide actually is full of a lot of awesome features. That is the basic workflow I did take you through. If you guys want to explore anything else, this guide walks you through it easy as that, step by step, exactly as I just showed you guys. Now also, if you want to have a quick reference, this website also has an awesome cheat sheet which does explain everything that you do need to know really quickly and all in one place. I do strongly recommend checking it out. Alright guys, if anyone has any additional questions on Git or anything like that, please do not hesitate to contact me. My email address is available from the email that you received this link from. So definitely go ahead and reach out to me. Alright guys, thank you very much. Once again, my name is Damon.